Moving to the next topic, that is services and dependency injection, or in short, DI. As the application grows, so does the logic, and chances are that logic needs to be shared across multiple places in the application. This is where services comes into the picture. What is a service? At its core, a service is just a plain TypeScript class that wraps properties and methods. It serves a crucial purpose, that is, centralizing and sharing logic across the application. For the question, why do we need services? Let's say you are fetching product data from a backend API, maybe a getAllProducts call. That data might need to be displayed on a dedicated products page, a home page, a shopping cart component, a search results page, wherever. We don't want to duplicate that API call logic in every single component. So instead, we place it in a service and that will lie outside the components. So any component that needs this data can simply request for it. This keeps our component focused on what they do the best, that is keeping UI and data in sync. Here is the key. Since we are dealing with TypeScript classes, it's important that all components interact with the same instance of the service. And for that, we need a singleton, which is a fancy way of saying we need a single shared instance across the entire application. If component A and component B each creates their own instance of the service, they would have separate data, separate state, and that defeats the whole purpose of sharing logic. For us developers, we need to focus on the project needs and not worry too much on ensuring design patterns, which is a painful thing to consider on top of the real task of building business logic. Here is where the frameworks comes to the rescue. Angular gives us a beautifully simple way to create singleton services. All we need is to create a TypeScript class, decorate that with the @injectable decorator, and pass one single special property called provided in root. And just like that, we have a singleton service ready to be used anywhere in the application. The provided in root property tells Angular, hey, register this service at the root level of the application, making it a singleton that any component can access. To consume the service within the component, it needs to inject the service and consume the logic within. We will dive deeper into how injection works in just a moment, but for now, understand the foundation concepts. Services keep the code organized, reusable, and maintainable. They serve as a data layer between our components and the backend. At this layer, we do data fetching from APIs, transforming raw responses into UI-friendly models, and delivering clean, structured data that components can consume effortlessly. This separation of concerns means components stay focused on presentation, while services handle all the complexity of data operations. Rather than speaking, let's create a service, wire it up to the component, and see how that goes. I've created a new file called log.service.ts. Let's start with a class. This is just a class. There is nothing special about it. We did export class logger. And to make this class a service, what we need is to bring in the decorator called @injectable. Once we import this, we need to decorate the class with the @injectable decorator. Not just that, we also need to pass in a configuration object, and within that, we need to pass in the provided in root. This says, hey, make this service a singleton and make it available everywhere in the application. This is the frame for a service. And to add logic to the service, let's create a method called log that accepts a message, which is of type string. It's a good practice to add the return type. Since this log message doesn't return anything, let's do void here. And within the log method, let's console, hey, this is a logger and this is the message. This is the most simplest service that I can imagine. And to wire this service within the component, let's open the IDE, Mind that the log.service.ts was placed within the app folder. Let me open the app.ts and put it to the side. Close this. Let me add a constructor. And within this constructor, let's do private log service and bring in our logger. Let me add a method called log, which calls this dot log service dot log and pass in the message. This is from the component. And to see this log, let's add a button in the app.html. Add a click event handler and wire it up to the log method we have. If we go to the web view, there is a log message button, and clicking on that will show a logger. This is from the component. Using a constructor to bring in the dependency for a component is one way, which is a standard way, but there is a more modern syntax which is a bit different from the constructor. We can do log service, give a property whatever we want, and then use the inject method, which comes from the Angular core, and then pass logger. The functionality will remain exactly the same. If I click on the log message, I'll still see the same message, but this is the more modern and preferred syntax going forward. You will see both syntaxes for injecting services in Angular projects, the newer inject function and the traditional constructor-based injection. Which one to use is a matter of context and preference. If we are starting a new project, use the modern inject method. It's cleaner and aligns with Angular's current direction. If we are working in a legacy application, stick with the constructor injection to maintain consistency with the existing code base. If we are migrating to a new Angular version, that's the perfect time to refactor and switch to the new inject syntax if we choose. But here is what really matters. Don't get caught up in the syntax choices. The bigger question and the fundamental concept you need to understand is the purpose of service itself. That is to delegate shared logic outside of components and consume it wherever we need it. Master that principle and the syntax just becomes an implementation detail. Whether we use the inject or constructor, we are accomplishing the same goal. That is accessing shared, reusable logic that keeps the application organized and maintainable. Let's move to the project exercise. Rather than reading this objective word by word, let me summarize what the ask is. Instead of using the mock recipes in the component directly like what we have now, we need to create a service, add a getRecipes method who returns this data, and a getRecipeById method to return single recipe once the user selects the same from the filtered list. Then the recipe list component should inject the service and consume the data directly from the service. The functionality should not change, but service becomes the source of truth for the recipe data. To scaffold a service, just like we have done the component, there is a shortcut using the Angular CLI. Let's do nggs followed by the name of the service. Here S stands for service and recipe is the name of the service that we need to scaffold. If we click the enter button, it creates the recipe.ts within the app folder. We can see that there is a recipe.ts, which is a service with all the frame already done for us. Let's set the base by bringing the respective imports, starting with signal, followed by the recipe model and the mock recipes. Let me also add some comments so that we have some guidance. Step 1 is to add a signal to hold the mock data. Then the mock recipes should be moved from the component to the service. we need to add two methods, get recipes and get recipe by ID. Once the service is ready, we need to inject the service in the component and consume the data. Let's start by creating a property called recipe and assigning that to a signal. Since this is a signal, we also need to provide the right types. Since this recipes signal is holding a recipe model array, we provide the appropriate types. Since signal always need an initial value, let's provide the mock recipes as the initial value. Moving to the methods, let's add the get recipes method, and as a best practice, we should always provide the return type. Let's also return this dot recipes so that from the component, when we invoke get recipes method, whatever the recipes we have here within the signal, that would be returned. Let's also create the get recipe by ID method that accepts an ID which is of type number. Let's add the return type for this method also. And what it does is return this dot recipes, and from the recipes, let's find the item that corresponds to the ID which is passed in. And to make the compiler happy, let's add the exclamation to explicitly say that don't worry about the undefined method, we will handle that. And to consume the service within the component, let's open the recipe-list, put the TS file to the side, close this, put it side by side. I don't need these comments anymore, so let me take this out. Let's inject the recipe service. And instead of the mock recipes, let's do this dot recipe service dot get recipes and then put a dot filter. And instead of doing this, let's do const selected recipe equal to this dot recipe service dot get recipe by ID and then pass the recipe dot ID. This will give us the selected recipe, and then do this dot recipe dot set and pass in the selected recipe. We no longer need the mock -recipes in the component because right now that's coming from the service. To see if this is working or not, let's move back to the web view. If I type C and click Caprese salad, I can see that the recipe is displayed. If I click on S, click on spaghetti carbonara, this is also displayed. So the functionality is working here. And to confirm, let's ask Gemini CLI. Alright, it read the recipe-list.ts file and says, excellent work. You have successfully created recipe service, moved the data management logic into it, and injected it into the recipe list component. This is a major step towards building well-architected and maintainable Angular applications. And let's move to the next topic, that is basic routing.